Okay. So please write the name of the topic. Probability. Probability. Clear? Now, yeah. So probability. So first topic is chance. Right. So chance means possibility of any event. Clear? So when we have a sunny day, so there is no chance of raining today. Clear? Sun coming up from the west, it is impossible. Sun rises in the east, sets in the west. So if you take a circle with larger area, then its radius will also be larger. It is certain to happen. It is certain to happen. Why? If you observe, this is a circle, right? So we have a circle whose radius is say r is equal to 1 cm. If I consider another circle whose radius is say 3 centimeter, 3 centimeter. So if I want to find the area of this circle, so area is what? Pi r square. Area is pi r square. So pi times 1 centimeter ka square convert into meter or just 1 centimeter ka square. So it is pi. If you consider this area of bigger circle, so it is pi r ka square. So it is pi times of r. R is what? 3 ka square is what? 9. So we have 9 pi. So area is 9 pi. That means if you take a circle whose radius is more, then the area will also be larger, right? So it's certain to happen. Clear? Next example, India win the next test series. So it may or may not happen. We are not 100% sure that India will win the match. So it may or may not happen. So we have 50-50% of chances. Clear? So this concept is called as possibility of an event. So chance means possibility. So question based on small example questions. So tell whether the following is certain to happen, impossible, can happen but not certain. I repeat, tell whether the following is certain to happen, impossible, can happen but not certain. First example, you are older today than yesterday. Okay, this is first example. Second one, a tossed coin with lands head up. Okay, so when you toss a coin, so there is a possibility of 50%, 50%. 50% will comes as head and 50% it can be a tail also, right? So when coin is tossed, will land heads up. This is second example. Third one, a die when tossed shall lands up with 8 on the top. So die, you know, right? When we play Ludo, so there is a die which has a number. So this is called as die basically. So it has number on its face. So this is 1, then we have 2, right? Then we have 6 also. Okay, and so on. So when die is tossed, shell lands up with 8 on the top. We are talking about this face. On the top, it has 8. Clear? Next one, next example. The next traffic light seen will be green. Tomorrow will be a cloudy day. So we need to categorize these examples as certain to happen, impossible, can happen but not certain. Can happen but not certain. Now see. So you are older today than yesterday. It's certain to happen. It's certain to happen. A tossed coin will land head up. Can happen but not certain. We are not certain. Why? Because it has 50-50% chances. The coin can have head as well as tail. A die when tossed shall lands up with 8 on the top. It is impossible. It is impossible event, right? This event cannot take place. Why? Because we have number of options 6. 1 to 6. Next traffic light seen will be green. So can happen but not certain. It can happen but not certain. Tomorrow will be a cloudy day. Can happen but we are not certain to it. Okay? We are not certain. Clear? I hope the concept is clear, right? Next one. The next article is called as, first we have seen what are chances. What are chances? Now next one is called as random experiment. Okay? Next article is basically random experiment. So I will give you an example to demonstrate what is random experiment. So when you toss a coin, okay? So when you toss a coin, It may turns out head or tail. ठीक है, या तो उस पे head आएगा और tail आएगा. So there are two possibilities. So an experiment is called as random experiment if it satisfies the following two conditions. First, it has more than one possible outcome. I repeat, it has more than one possible outcome. Okay? Either yes or no. There are two options. Head or tail, there are two options. It is not possible to predict the outcome in advance. We are not sure whether head will come or tail will come. Clear? So any experiment is called as random experiment if it satisfies two conditions. First, it has more than one possible outcome, and the second one, it is not possible for us to predict in advance. It is uncertain. So these are called as random experiment. Random experiment. Clear? For example, we are playing say football, okay, with opposite team. It has more than one possible outcome. Either we will win or we will lose. Okay. Second one, we cannot predict whether we lose or whether we win in advance. So such experiment, such event is called as a random experiment. Okay. Next one. Next one is called as outcome and sample spaces. Next topic is outcome and sample spaces. So possible result of a random experiment is called as outcome. I repeat, possible result of a random experiment is called as outcome. Example, rolling a die. So when you roll a die, so in this experiment, we have 1, 2, 3, 4, 5, 6. So these are the numbers that can come on the face of a die. Clear? So the set of outcomes are 1, 2, 3, 4, 5, and 6. It is important to note that we always put curly bracket. Set of outcomes are represented by curly brackets. So we just put curly brackets. We write the numbers 1, 2, 3. See, each number is separated by a comma sign. Each number is separated by a comma sign. Clear? So the set of outcomes is called as sample space. It is called as sample space, and we represent sample space by letter S. Clear? Now each element of sample space is called as sample point. So if I consider this, so this 1, 2, and 3, they are called as sample point. Sample point. I hope the concept is clear, right? So set of outcomes is called as sample space, and each element is called as sample point. Each element is called as sample point, right? For example, when you toss a coin, so either we can have head or we can have tail. So there are two sample spaces. There are two sample spaces, and each outcome, each element is called as sample point. So head and tail, they are called as sample point. Sample point. I hope it is clear, right? Till now. Our next one. Now, next we'll talk about the term probability. Probability, right? For example, I will just demonstrate with example, right? So suppose we have a coin, and on the coin, the front surface where one is written, number is written, that is tail part. So this is tail part. And where we have Ashoka emblem, right? This is an emblem. So we have head. So this is head basically, head, and this is tail. So number where number is written on the face of the coin where number is written is always considered as tail. So this is tail and this is head, right? So when a coin is tossed, so we have two possible outcomes, either head or tail. Either head or tail. Clear? Now there is a possibility of 50-50%. Either head will come or tail will come. There is a probability of 50%. Yeah, possibility of 50%. So probability of getting head. So probability of getting head means number of favorable event. For example, when you toss a coin, there is a possibility of getting one head. There is a possibility of getting one head, right? So 1 divided by total number of outcomes. Either head or either tail will come. So there are two possible outcomes. So 1 over 2 is nothing but the probability of getting head. 1 over 2. Similarly, you can calculate probability of getting tail. So tail, number of favorable event, that is 1, divided by total number of events, divided by total number of outcomes basically. So 1 plus 1, that is 2. Either head or tail will come. So 1 plus 1, that is 2. So 1 over 2. So probability of getting tail is also half. So we can say there is a possibility of 50-50 chance. Clear? So this is a concept of probability. Probability. Now see, when you throw a die, so this is basically a die, right? Ludo. So sample space, how many sample spaces we have? We have 6. So 1, right? This space has 3. Then we have 2, then you have 6. So there are total number of 6 sample spaces. So all 6 outcomes are equally likely. Okay. So each of 1, 2, 3, 4, 5, 6 has 1/6 of probability. For example, in exam, they will ask you what is the possibility or probability of getting 6 on the field top. So possibility or probability of getting 6 on the top. So we have number of favorable outcome is 1, and total number of sample spaces. How many sample spaces we have? Total number outcome, we have 6 outcome. 6 outcome. So divide by 6. Divide by 6. So 1/6 is the probability. 1/6 is the probability of getting 6 on the top. Same is the probability for getting number 2, number 3, number 1, and so on. So this is how you can calculate probability of an event. Clear? Probability. This is how we just generally calculate probability. Next one. Now I will introduce a formula of probability, right? So probability formula is basically probability is written as P, then you have E, that is probability, right? Number of favorable outcomes divided by total number of possible outcomes. I repeat, this is the important formula. Probability is equal to number of favorable outcomes over total number of possible outcomes. Total number of possible outcomes. Clear? This is a particular formula. Just learn this formula by heart. Number of favorable outcomes divided by total number of possible outcomes. Now there are cases in it. So first case, when the event does not happens, so it has a probability of 0. Okay? It has a probability of 0. An event that is sure to occur, so it has a probability of 1. Sure to occur, probability 1. Clear? So probability range lie between 0 to 1. So 0 is the upper limit when there is no event that will happen, and 1 is the probability when we are sure that the event will happen in future or it will definitely happen. That is 1. So probability of happening event plus probability of event not happening is always equal to 1. I repeat, probability of event happening plus probability of event not happening. So not means we just put bar over it. See, we just put bar over it. Is always equal to 1. Is always equal to 1. Clear? I repeat, probability of event happening plus probability of event not happening is always equal to 1. So the summation is always equal to 1. Okay. I will be using this result while solving the problems. So for solving numericals, we require 2 things. Right now, this particular formula, that is important one, and the second one, this formula. Probability of event to happen plus probability of event not happening is always equal to 1. Yeah. Now next, examples based on this particular concept, right? Find the probability of, first one, the sun coming up from the west. The sun coming up from the west. So it is impossible. So probability is 0 basically. Probability is 0. Second example, an ant growing to 3-meter height, which is impossible. So the probability of the event is 0. Probability of the event is 0, right? In both the examples, it is impossible, right? So probability is 0. Next one. Now numerical based on this particular concept. So first question. So question says that a coin is tossed 1,000 times. So basically, generally we have a coin and a coin is tossed 1,000 times with following frequencies: head 455 times, tail 545 times. Compute the probability of each event. They ask you to find the probability of each event, right? So see. So first I will compute the probability of getting head. So probability of getting head that is equal to number of favorable event. First I will write the formula for probability. So probability of any event is equal to number of favorable event divided by total number of outcome. Total number of outcome. So probability of getting head is nothing but number of favorable event, which is nothing but 455 over total number of outcomes. So in this particular example, total number of outcome is the total number of coins tossed. So it is 1,000. 1,000. Clear? Simple, right? You can simplify it further. You can simplify. So 5 nines are 45, 5 ones are 5, 5 twos are 10, 200. Clear? So 91 over 200. This is the probability of getting head. Now second part, probability of getting tail. Probability of getting tail. Probability of getting tail. Probability of getting tail. So what is the frequency of getting tail? That is 545. 545 over 1,000 over 1,000. Now simplify. 5 ones are 5, 5 nines are 45. Over 5 twos are 10, 200. So 109 over 200. 109 over 200, right? So basically, this is the possibility of getting tail. Probability of getting tail. I hope the concept is clear now. It's easy basically. You need to just simplify. Yeah. So we are getting the same thing. So we have just calculated in terms of fractions. So decimal we have 0.455. In decimal we have 0.0545, right? Now, as you already discussed, in order to check whether your answer is right or wrong, we have learned one concept. Probability of any event plus so probability of getting head plus probability of getting tail is always equal to 1. See, is always equal to 1. Probability of getting head plus probability of getting tail is always equal to 1. Clear? So this is how you can check your answer, whether your answer is right or wrong. I hope the concept is crystal clear, right? So this is first variety of question that examiner will ask. Now next one. Second variety of question. This is type 2. Type 2. Clear? Now type 2 states that two coins are tossed simultaneously 500 times. So frequency is given. And we get two heads one head, no head. So two head is 105 times, one head 275 times, no head 120 times. Find the probability of occurrence of each of the event. We need to find the probability of occurrence of each of the event. Yeah. Yes. Now see how to attempt such type of problems. So visualize, right? While solving problems regarding probability, we need to visualize a lot, right? So two coins that are tossed simultaneously 500 times, we get two heads 105 times, one head 275 times, no head 120 times. Find the probability of occurrence of each of the event, right? Now see, in this particular questions, so number of trials or number of possible outcome is basically 500. It is already given in the question, 500. Clear? So first what we do, we need to find the probability of two heads first. Probability of two heads. So probability of two heads will be what? Probability of two heads. Two heads. 105 over 500. Over 500. Clear? 105 over 500. That is 0.21. You can simply divide, right? This is the probability of getting two heads. Next one head. Next one, probability of getting one head. So probability of getting one head. Probability of getting one head. One head. So what is the frequency? Frequency is 275 times. 275 over 500. So frequency is 275 over 500. 275 over 500. It's easy, yes. It's not tough at all. It's 275 over 500. You can divide, you will get 0.55. So this is how we can find probability of one. Now next part deals with probability of no hits. Probability of no hits. Probability of no hits. No hits. So no hits 120 over 500. 120 over 500. So 2 times 2, 6, 12, 25 divide, you will get 0.24. 0.24. Clear? So these are the values for probability of two heads, one head and no head. Now, what we do, we just add all these events together. Add all these events together, right? It should come equal to 1. So just add probability of two heads, one head and no heads. So 0.21 plus 0.55, that is 0.76 plus 2.4, that is near about 1. So probability is 1. Sum of probability of all the event is always equal to 1. Clear? Any doubt in this particular question? Is the concept is clear? It's easy, yeah, it's easy. Just visualize, think, and in the end, you need to just check this step. So probability of first event plus probability of second event plus third event is always equal to 1. Is always equal to 1. Hope the concept is clear, right? Chal. Next one. Now see this question. Now this is interesting. So a die is thrown 1,000 times. So we have a die and it is thrown 1,000 times with a frequency of outcomes 1, 2, 3, 4, 5, 6 as given in the following table. So outcome is given, frequency is given, right? Outcome is given. Outcome is 1, frequency is 179. 2, frequency is 150. 3, frequency is 157. 4, we have 149. 5, we have 175. 6, we have 190. And they ask you to find the probability of getting each outcome. Okay? Each outcome. So it's quite simple. It's interesting. So is the question is clear? So we have a die. So when you throw a die 1000 times, the probability of getting 6 is 190. Of getting 3 is 157. Of getting 1 is 179. They ask you to find the probability of getting each outcome, right? So probability of getting 1. Probability of getting 1. So what is the probability of getting 1? So 179. This is 179 over 1000. Clear? Similarly, probability of getting 2. Probability of getting 2. It is 150 over 1000. Probability of getting 3. 157 over 3 over 1000. Clear? Probability of getting 4. Probability of 4. 149 over 1000. 149 over 1000. Probability of getting 5. 175 over 1000. Over 1000. Probability of getting 6. 190 over 1000. Over 1000. Clear? Now it's simple, right? So when you divide any number, when you divide any numbers by 1000, 100 and tens, just count the number of zeros you have, then put decimal by counting the number of digits. For example, you have 1000. 1000. How many zeros? We have 30. 30. So 1, 2, 3. After 3 digits, just put decimal sign. So it is 0.179. 0.179. 150 over 1000 is 0.150. Of getting 3, is 0.157. 0.157. Of getting 4, over 4, it's 0.149. Of getting 1000, 5, that is 175 over 1000. That is 0.175. Clear? Of getting 6, so 0.190. 0.190. Clear? Last step, just add all the probability, you'll get 1. So probability of getting 1 plus 2 and 3 and right 4, 5, 6. So when you add, I will use the term summation. Summation means addition, right? So addition of all the possible outcomes, basically probability. So 0.179 plus 0.150 plus 0.157 plus 0.149 plus 0.175 plus 0.190. So when you add, you'll get 1. Okay. So this is how we just solve probability problems. I hope the concept is clear. Okay. So this is basically second variety of problems. Okay, this is type 2, second variety of problems. Any doubt in this particular question? Okay. Next one. Yeah. Next one. So next question says that on one page of a telephone directory, right? Initially, we used to have telephone directory. Okay. So directory is basically a book that was sanctioned by telephone department. You can just go and just check the names of the customers, right? And you can call. It is just same as that of Just Dial right now. Yes, so Just Dial is a modified form of directory only. So on a one page of a telephone directory, there are 200 telephone numbers. The frequency distribution of the unit place digits, for example, in the number is this one. And unit place is 3. Unit place means we are talking about this place. No? So first one is unit place, tens place, hundred place. So if I write say $320 or 320 rupees, right? I just use a dollar. So this is unit place. This is tens place. This is hundred place. Clear? Unit tens, 100. Okay. Now in this particular question, they have given you the number like this, and they say that unit place digit is 3. So digit is given, frequency is given. So without looking at the page, the pencil is placed on one of these numbers. That is, the number is chosen at random. Okay. So basically what we are doing, we are choosing a number at random. What is the probability that the digit in it is unit place is 6? So they ask you, okay, what is the probability that the digit in its unit place is 6? Unit place is 6. So they ask you to just to find the probability. Okay. Now same steps we have to repeat. Okay. So probability of digit is 6. So 6 means this column. Just observe this column. 6. What is the frequency? What is the frequency of number 6? That is 14. The frequency is what? 14 divided by total numbers. Total numbers. So what is the total number? 200 telephone numbers. Okay. So 14 over 200. 14 over 200. So 2 times 7 is 14. 2 times 100 is 200. So it will be the, see, so it is 7 over 100. That is 0.07. 0.07. 0.07. I hope the concept is clear.